That brown dwarf is 23 million years old. And you know what? From that pixel, I can definitely tell it's a brown dwarf and not a Jupiter, or not like a Venus, or not just a giant asteroid. You can definitely tell it's a brown dwarf, man. Like, I'm trying to invent a jetpack that runs on gravity. I'm not doing well on it.
The word star, man, it's an illusion.
Stay cool. I don't know if you know this. Thor News is for winners, and that's why you're here. So stick around. Hit the button, baby. This is a Thor News presentation. Thor News presents Party Dance Time. This is kind of old, but that'll be interesting. What the hell is Forbes doing talking about brown dwarfs, man? Would a brown dwarf near us cook the Earth? Wow, that's a weird way to put it, Jillian Scudder. Are you a reptilian? Are you looking to cook Earthlings? Cook is a specific kind of word. You work in astronomy, so scientists and astronomers aren't always that great with words. I'll let it slide for now. But I got my eye on you, Scudder. If a brown dwarf came close to Earth, how hot would it get? Ooh, all right. Would it cook us like a roast in an oven? See, there you go, man. You eat a roast. You know what I'm saying? Like, who's going to come by and eat us? They have to come out soon because food spoils. Even if it was human meat, I would guess. I know I'm not really a human meat expert. Never had it, never will. All right. This artist's conception illustrates the brown dwarf named 2MASS 222-8289-431-026. Can we nickname that food, please? NASA's Hubble and Spitzer space telescopes observed the object to learn more about its turbulent atmosphere. Brown dwarfs are more massive and hotter than planets, but lack the mass required to become sizzling stars. Okay, brown dwarfs are kind of like half stars, half planets in my mind, but whatever. Their atmospheres can be similar to giant planet Jupiter's. Spitzer and Hubble simultaneously observed the object as it rotated every 1.4 hours. Can I see those photographs? Obviously that photo's not a photo. The results suggest wind-driven, planet-sized clouds. Brown dwarf stars are bizarre objects, kind of like me, which straddle the gap. All this sexual innuendo about brown dwarfs. I don't know if I can take it. I don't know if I can take it. All right, we're straddling gaps between fully functional stars and their massive planets like Jupiter. All right, we kind of agree. That's good, I guess. Brown dwarfs aren't massive enough to start nuclear fusion in their cores, which is the process by which our sun reaches such tremendous temperatures. Without a large source of heat in their cores, brown dwarfs can't do anything to maintain a stable temperature and cool over time. Kind of like me. I get cooler over time as they radiate their heat away into the void. That's what the world kind of feels like right now. The world feels like a void. Void of humor. In many ways, we look to Jupiter as a model of what a small brown dwarf might look like. There we go. Jupiter, our sun's binary companion. But like many boundaries in astronomy, the border between a large Jupiter-like planet and a small brown dwarf is very, very fuzzy. Fuzzy. I would say straddling fuzzy gaps, but that would be way over the line. Do you count a brown dwarf formed with a much larger, brighter star as a dual star system, or as a single one with a very massive planet? What? Oh, okay, yeah. I consider it as a dual star system. That's why, like, Jupiter and the sun is a dual star system. Thanks for asking, Jillian. I appreciate it. Let's get this thing heated up. There are a few things we know should change. Brown dwarfs should be hotter than Jupiter, and this is largely because they contain more mass than Jupiter. Typically, at least 10 times more than what Jupiter contains. But how does this mass mean they're warmer? I said earlier that brown dwarfs like Jupiter are incapable of burning hydrogen to create their warmth. Brown dwarfs rely on another mechanism, which is the crushing force of gravity. Gravity. What have you done to me? I'm trying to invent a jetpack that runs on gravity. I'm not doing well on it. If you compress a fixed amount of gas into a smaller space, through any means necessary, its temperature is driven higher. This works if you're dealing with a canister of air on the Earth or with an entire planet. For both Jupiter and brown dwarfs, gravity is continually crushing their gas down into a smaller and smaller core until some force resists it. The force that does the resisting depends on how much crushing pressure you have to start with. For a brown dwarf, it's the pressure of electrons resisting getting any closer to each other. This gravitational compression of the gas, which makes up the brown dwarf or Jupiter, increases the temperature of the gas of that of the brown dwarf. Interesting. So Jupiter just keeps on compressing? Good to know. Unfortunately, this gravitationally triggered temperature isn't particularly good at making anything warmer. Jupiter clocks in at minus 234 degrees Fahrenheit, or negative 145 degrees Celsius, at its cloud tops. The core is warmer, as you might expect. We know because we've been there. We've been to the core. We've sent some like Jupiter core robots that have been like, yep, I tasted the core and that thing is hot AF, RN. The coolest brown dwarf known, so far, still in negative temperatures. But it's the sort of negative you can feasibly get in a nasty cold snap on our habitable Earth between negative 54 and 9 degrees Fahrenheit, or negative 48 to negative 13 Celsius. There's a suite of brown dwarfs that function at very human temperatures, roughly body temperature, really, or the temperature of a cup of coffee, are often invoked. Even the warmer brown dwarfs tend to get up to the temperature of an oven on broil, so you can pretend to visit a brown dwarf in the comfort of your own home. by setting your oven to max and opening the door. That just sounds weird and dangerous. Obviously, don't visit for very long. I don't want to be responsible for your oven-inflicted sunburns. And don't leave the gas stove on, people. I don't want scientists blowing you up. You gotta watch out for them dark matter scientists. Seriously. Super seriously, bro. Comment on the story? Hell no. So if we wanted to pull one of the things closer to Earth and see what effect that would have on our planet, we can already see that we'd have to pull them very close to Earth, which is not advised for a number of reasons. If we simply replace the sun with a brown dwarf, we would very rapidly freeze. Wait, you're telling me that the sun affects climate? This is revolutionary, Jillian. That's crazy. It's crazy. The sun affecting the climate? Wow. As a sudden drop in light from our replacement sun wouldn't be enough to keep water at a liquid temperature on our planet. On the other hand, once you start throwing massive objects around the solar system, the likelihood that any individual planet will stay on its current orbit drops massively. Planet 9, calling Planet 9, paging Planet 9. Where are you, Planet 9? And the window within which water will remain liquid is a narrow one. In fact, if you wanted to replace the sun with a brown dwarf and keep liquid water, you probably have to put it where the moon is or where the sun don't shine. You can stick that brown dwarf where the sun don't shine, baby. Assuming a star that's 100,000 times less luminous than the sun, what? You lose lots of what we take for granted now from our sun. Yeah, science takes a lot for granted from our sun. It's like to keep the sun under 4-privet drive. Harry Potter joke. Like visible light, but the ambient heat may just keep water flowing with the brown dwarf dominating our skies. So I'm confused. It sounds like, what? I don't know. This article didn't make no sense. Maybe I'm just dumb. Maybe a little bit of both. Okay, I'm going with Forbes Article. A little bit of both. You can explain it to me in the comments. All right, thanks, guys. I know I'm a little rusty, but I'm getting back up to speed. There you go. I think there's a picture on the right that proves without a doubt that brown dwarf is 23 million years old. And you know what? From that pixel, I can definitely tell it's a brown dwarf and not a Jupiter or not like a Venus or not just a giant asteroid. You can definitely tell it's a brown dwarf, man. Like, I'm trying to invent a jetpack that runs on gravity. I'm not doing well on it.
The word star, man, is an illusion.
Stay cool. I don't know if you know this. Thor News is for winners, and that's why you're here. So stick around. Hit the button, baby. This is a Thor News presentation. Thor News presents Party Dance Time. This is kind of old, but that'll be interesting. What the hell is Forbes doing talking about brown dwarfs, man? Would a brown dwarf near us cook the Earth? Wow, that's a weird way to put it, Jillian Scudder. Are you a reptilian? Are you looking to cook Earthlings? Cook is a specific kind of word. You work in astronomy, so scientists